Our journey begins where stars are born. This is the Lambda Centauri Nebula, nicknamed the Running Chicken Nebula, glowing in infrared light captured by NASA's Wide-Field Infrared Survey Explorer. Clouds of gas and dust collapse here under gravity, igniting new suns within the Milky Way. Not far away, in the constellation Sagittarius, NASA's Spitzer Space Telescope captured another vast cloud during its glimpse survey of our galaxy's crowded plain. Astronomers nicknamed it the Godzilla Nebula for its imagined silhouette. Both images reveal invisible infrared light made visible, windows into the churning nurseries where our galaxy continually renews itself, one newborn star at a time. Behind every glowing nebula image lies an unglamorous truth. Discovery depends on computation. This is a nebula containerized server at NASA's Ames Research Center, part of the infrastructure that processes torrents of data streaming down from orbiting telescopes. Raw signals from instruments like WISE and Spitzer must be calibrated, cleaned, and rendered into the vivid images we recognize. Supercomputing clusters like this one quietly power the science of space exploration, turning faint infrared signals into pictures capable of stirring wonder. As we move deeper into the cosmos in this episode, remember that every image was made possible by machines like this one, working in silence on Earth. Beyond our own galaxy lie countless others, each with its own architecture. NGC 3455 in the constellation Leo displays the barred spiral structure astronomers classify under the Hubble sequence. Farther out, in Ursa Major, the galaxy M81 was imaged in ultraviolet light during the Astro-1 shuttle mission, revealing hot regions of active star formation invisible to ordinary eyes. And in the constellation Sculptor, Hubble's advanced camera for surveys captured NGC 24, a shining disk first noted by William Herschel over 2 centuries ago. Together, these galaxies remind us that spiral structure, arms of gas, dust, and stars swirling around a bright core, is one of the universe's most common and beautiful patterns. Closer to home, our journey turns to Mars. NASA's Mars Global Surveyor used a laser altimeter, called MOLA, to measure the elevation of the planet's northern hemisphere with remarkable precision, building a topographic map of ridges, basins, and plains. Meanwhile, the Mars Odyssey orbiter used infrared imaging to peer into Terra Meridiani, revealing layers of rock exposed at the surface, clues to a history shaped by wind, sediment, and possibly water. These tools work together, one measuring height, the other revealing composition, to reconstruct the geological story of a planet that once may have looked very different from the dry world we see today. Among the most tantalizing Martian discoveries came from a single image taken by Mars Global Surveyor during its aerobraking phase. Viewed with 3D glasses to reveal subtle surface relief, the picture showed features resembling seepage sites, places where liquid groundwater may once have emerged onto the Martian surface. It was among the first pieces of evidence suggesting Mars was not always a frozen desert, but a world where water, however briefly, could flow. This single frame reshaped how scientists thought about the planet's climate history, and it continues to guide the search for habitability across the solar system. Our journey ends at the largest planet in the solar system. Jupiter's atmosphere churns with storm systems more violent than anything on Earth, their swirling bands driven by intense internal heat and rapid rotation. NASA imagery has probed this storm activity in detail, tracking turbulent structures that rise and fall across the cloud tops. Most famous of all is the Great Red Spot, a storm larger than Earth itself, raging for centuries without end. From glowing nebulae to galaxies, from Martian plains to Jovian storms, this episode has traced a single thread, a universe in constant motion. If that journey moved you, subscribe for more explorations of the cosmos.